Okay, so sorry we had technical issues, we was fighting with the demons. So yeah, welcome back to our insightful podcast series, part number 2, where we delve into the world of building controls. So today we will touch the topics about case studies for energy using advisory platform and APC services. But before that, we would like to jump back to recap, which we talked in previous session, where we went through about evolution of building controls. Yeah, and today, once again with me is Donatas Karšauskas, is the CEO of Exergio. So Donatas, for the audience, could you please describe about the company and mission you're doing in a couple of words, and we can get back, to the levels of building control. And for those who's watching, if you have any questions, please put it in the section down below, so we will try to answer. So yeah, hey Donatas.
Hi, hey, thanks. So you put a very good word, mission. We all in the same mission, especially now when the so huge traction from everyone, starting from governments, finishing with the banks and everyone, to put assets for real estate into zero emission.
Yeah.
And efficiency is a huge topic for that. So this is what we're doing for already 12 years. And we're happy to receive such a huge traction from the market. Even though it's like we're doing one and only thing, is reducing consumption in the buildings. And we started 12 years ago, and we went through all the points we can do something to reduce the costs for utilities. And we started from some consultancy works, doing like audits and finding retrofits to improve building operation and efficiency. Later on, we just put our hands on and we started to make retrofits, to catch up. What are you calculating? Does it really get?
It's not enough to have just a paper. Yeah.
Exactly. So we did that, and we had to make more energy saving with less investments for our clients. So 4 years ago, we indicated that the performance of building controls is lowest hanging apples, because a single sensor can affect the consumption sometimes up to 10%. So we started to deliver energy performance controls, energy performance contracts, and such services, and to improve controls for our clients. And years go past, we indicated that for engineers it's not possible to manage huge numbers of data we're having now from the buildings. So 3 years ago we created a platform which helps to automate, to use bots and algorithms to find out insights for building energy reduction. So that's the story, and we are in the line of CO2 reduction and the targets we all have.
Okay, so thanks for short explanation. So previous session we talked about the BMS evolution during the last decade, and how it changed and why such a systems is needed. So remember you were showing the slides with 5 level of controls. Could we get back to it and take a deeper explanation?
Okay. So I'll try to share the slide. So this is the essential for anyone in the market who is involved with operations of building. We have to understand at what level of controls are in a specific building. And if we start from the first one, I call it device level. It's a situation when equipment which is responsible for energy consumption, mostly HVAC, lighting, sensors and meters which calculate the consumption and give data, they are standalone devices. So it's imagine the situation: you are having some devices, you are not next to them, so you do not understand what's happening in the building. And that results, my complaint comes in, that results going back and forth to find out what's happening in the building and to fix some situation. So it's waste of time and human resources to understand how building is operating.
I think it's not waste of only time. You definitely will agree with me. It's a waste of energy consumption, and the losses, I think, is huge.
Exactly, that's the point. When At first, it was like human resources. They are still active, but remember we had peaks and energy crisis.
Yeah.
When the prices went up, it's another point for that to have systems in the building came in. And the same example, if you do not understand what's happening in the buildings, you can face heating station might have like broken actuator, and you have open heating supply. You supply 70 degrees while outside is +5.
Okay.
Everyone's overheating, windows are opened. I'm just making some mystical, but we had these kind of situations. You can understand that without any systems and remote connection and seeing, you're losing money minute after minute.
Yeah. So seeing your slide, I do understand that this remote connection is like a tool. Yeah. If we're talking about the level 2, the BMS system. So from my perspective, give me a tool to fix a car. It won't start, believe me. Yeah. So I don't want to sound offensive. Oh, sorry. Yeah. I don't want to sound offensive, but is it not the same with the engineers who's working with the BMS systems?
I know your car fixing skills. It's true. I mean, tool is you have to have hands and brains to use the tool. The same is with the BMS systems. I would say that
you must have a knowledge,
the knowledge and an approach. And we have like I would say 3 levels of tool users. We still have, I would say, 0 level of like users or engineers.
Who is in the 0 level?
Are the ones who do not have a BMS password. And I mean, the system is implemented, and you ask for it. And say, I don't know. I know there's a computer somewhere, but it's not usable. Even investment is done. Second level is like reactive engineers who get the call and they say, okay, I'll open the screen, I will check. Okay, I increase the set point. No complaints from if it's too cold or too hot. But there's another level who are just using the BMS, crawling it and putting algorithms in their heads. They're making experiments and think how settings of the systems may be improved to reduce the consumption. And they are proactive engineers. And we are the ones. I mean, we are paid to be proactive engineers in energy performance contracting. While we're delivering the services. But again, there's a tool. We spend so much money scrolling all of it, and we need to have a like upper level system which automates the process for analysis and a deep analysis of the performance. And I mean, this is the third level. When we go to there, it makes operations faster, less human resources, more insights, and it actually works not only for us but for all the market. By the way, how is the market? How are those systems? I mean, in a globe scope. In a globe scope, I mean, you can find the researchers that there is one problem. I'm always indicating that we are having so much data, but you can find researchers that only 10% of data is used to give it to the result, and so there is attraction to use this data, and a lot of companies and we have advisory level platforms which are doing a lot of analysis and giving you the insight, and this market is growing in a huge pace. I mean, if we talk about IoT, IoT is so trendy. Everyone is like, you go to the exhibition in London, IoT is everywhere. So and the market is of IoT is growing 25% yearly or something like that. This kind of advisory systems, analysis systems, the market is growing more than 50% a year. So it's huge. Everyone is now jumping on that wave. Okay. So if the market is growing so fast, I do believe there's plenty of, such a systems which do the same mission, So how to not get lost in that field? I mean, which systems is worth to use or which is not? And what's the Exergio main advantage comparing to other players in the market? Again, it's having fancy tools, and there are a lot of systems being in that mission to analyze building performance and give insights. But again, we're getting back to your car fixing skills. even if you're having the best tools, and advisory does another step for analysis and gives you the insights. We can jump in later on in showing the real cases how it's possible to use the data.
So it depends on the driver, yeah?
It depends on the driver, but you do not have to leave because action has to be taken. If you have the analytics, the best reports, you have to take actions. That's why we are making into the package. We're packaging energy performance contracts where the essence is to save energy according KPIs. And we're using the tools, tools, right commercial deal, and you can follow the bottom line where every client is needed to reduce the consumption and to give good CO2 emissions to like ESG report or something like that.
Okay, but I see in your slides we have also the fifth level, it's artificial intelligence. So how do you use it? I know often, not so often.
It has to be. It's coming. There is like a huge boom in the market. It's super trendy at the moment. Everyone ChatGPT things and so on, and it's definitely used for building and real estate. And but we have to understand that you have to go in steps. You cannot jump from like level 2 having a BMS and then the next level is go to Strive, because each building have each specifics. People inside, requirements for like operation are specific, and you can use AI only after level 4 when you agree with the maintenance companies, when you agree with the building owners or people inside, what are the rules they want to have. Because if you launch AI at the first day, you might get some energy saving results, but you can have really big problems with comfort level and so on. So it has to be a very like a step-by-step agile approach, and we use it, but only after the level 4, and it's booming. I mean, it changes month by month. If we're going back application a month ago and what we have now, it's like day and night.
So let's say the building already has these 5 levels. So how it affects energy consumption? Do you have, let's say, something to show with the client case studies?
We can just I will go in going from like results at first. I'm sharing the slide. So it's applicable for bigger buildings with more data and more systems inside. And by empowering this data, huge number of data for buildings like office buildings, retail chains, shopping malls, warehouses, fitness clubs, where you have a lot of systems and intensive usage. As you can see, the saving amount is huge. I mean,
I see up to 26%.
It can be case by case, but every different building has its story. And when we talk about these numbers and go jumping into some case studies or examples, we will hit that for sure. It's important to validate how they are calculated.
That was my upcoming question. How you guys validate or calculating the savings? So
that's the question everyone is asking, because if you are just this business model, it's commerce things. You pay money, you want to get the result.
Of course.
So the validation is it's a little bit more complicated, and I want to give you an example. If you have energy efficiency project, and there are 2 types of projects. It's like CapEx-based projects, when you just decide to retrofit your chiller with higher efficiency. Then it's like hardware implementation. You have the numbers of COP before and after. You can calculate it, and usually companies just invest, make the calculation, don't even follow that, but it's clear. I made the measure, changing the chiller. It's clear for everyone. If we talk about software approach and building management and performance approach, there is no one measure. There might be a set of different measures. They are changing according to like season. And it's going on continuous process. And when we are talking about savings, there we have to go into understanding that there's a huge data and measures might be smaller. Going back to validation, we have to have system to calculate it, because everyone who is in that market knows that there is no possibility just to compare invoices and say it's saving or not saving.
Yeah.
So it's very important at the first point to make energy calculation model based on historical data, accumulating a baseline involving driving factors, degree days, occupancy level, sometimes even sunny hours.
Okay.
You create the model for the client, you prepare it for him, and he says, yes, I understand it. Very good that we're having like driving factors which take into account of the calculations. It's clear for everyone, transparent, and this is the first step.
Okay, but I think you told me you're going with the monthly reports, to the client.
Yeah.
Let's say, to show what actions you made, how let's say energy consumption you save or cut. So, but I think where's specific measures, where you must show the client, because we're always asking, how you did that.
Okay.
So do you have any cases like examples to show how you showing, your clients which, let's say, steps or malfunctions you found, and it's data proof based, energy consumption, and showing the client how you save the energy.
Okay. Yeah. That's the case. I would say that at any case, there are a number of measures. And before going into some examples, I know you're keen to see them as soon as possible.
Of course.
But I just want to go in a little bit of explanation of how these advisory systems are worked, to understand that there's a numerous of points where you can hit on, and different buildings have different stories.
Okay.
So I'm showing the print screen, very simple logical idea of a working flow. Then I will show it in platform itself. But the idea is to catch up all the data from HVAC or lighting or sensors and meters. Again, is to get the full data, what's happening in the building.
Basically from all the equipment, yeah.
Exactly. So we put it into a single database. It's very important to have even different systems into same database, because sometimes it's happening that AHU units are working separately with the VRF systems.
Okay.
It's a BMS, but they are working separately. But we have to get all the data in one database, because they are in the process, they are connected, and you have to cross-check, because one can be cooling at the same time, another can be heating or just trying to turn on heat recovery process in the logic. So we're putting it into single database online, and on the other side, it's the key thing. It's rules which have to be applied to catch up the insights for building malfunctionings or improvements. We call it best performance algorithm scenario.
Okay.
It's the set of rules, and we developed for some of the buildings, it might be 200 of them.
Okay, so we have
and you just have to choose which applies to which. And what is good that we can apply any. We ask for our clients, do you have the feeling, or tell us, how do you think that operations are best in the building?
Okay.
They can also, because they understand the buildings, they can give us the description of that. We are taking it very easily into algorithm, and we apply it. The main idea is here that it might be 200 or 300 algorithms checking, and the measures might be for up to 15 or 60 measures, but the small ones per each month. And this goes to case study results with small retrofits and measures. It's completely different that, I changed the chiller and I saved the energy. It's more soft, but it's very important that investments versus the result, return of investments is times less, and it's better in commercial perspective.
I'm totally agree with you, because imagine every building has thousands of data lines, and punching up to 24/7 every single day. So it's a different story every single time, but approach to that stays the same, no doubt. So, but anyway, we must understand where our savings comes from. Give us example according to that, if you, have slides or something to show.
I can try to go into the platform itself we're using.
At the same time, I will check, maybe someone hit us with questions.
Do we have questions?
Actually, I can't connect. I don't know. Neris.
Are we still online?
Yes.
Either we just having problems second time or per day.
Yeah. But I mean, does somebody ask any questions?
Just a second.
Yeah, because I'm trying to open it. It's not opening. Maybe I have a connection problems. I don't know.
I don't see questions.
Okay. Yeah, so feel
Yeah.
free. Yeah, you can.
Okay, thank you. So I'm sharing right now I want to give you some idea of the operation which leads from many things and algorithms, the operation in the platform itself, how it leads to savings. And this is one example of a dashboard we're having in our platform. It gathers all the information from the building, and we can see some sections here which are very important for engineers who are operating with the building. For us, it's very important to have at the left side, you can see the comfort status today. Imagine the building having 600 rooms and room thermostats, which are responsible for microclimate. So in the BMS to scroll and to see if somewhere is problems, it's 6 ages. Here I have the problem that I can see the list that today we're having problems with overheated areas. It's 14. I have the list here.
How many rooms is there?
600, something like that.
Okay.
It's a big
building.
complex of the that. So we can track them and we can see by numbers which rooms are in problem. But this is not the main tool. I mean, this is to work with the comfort. The next stage is to get the list of insights from the system. They accumulate the data and go through various algorithms, and it there gives us the list of insights we have to look for and to do some changes. So this is like I can check. I can move to other one. This is the list, but I want to show you that we are doing like continuous process in that. It's launching the system. So again, we have the same list of insights. System already gives for us what has to be done. Yeah, we can filter it by some system types and so on. For us, it's very important to filter them by errors and in type of insights. And what is important and what's the thing from you are asking where the energy savings come, and when we say there are a lot of small measures, but these small measures might be grouped into bigger groups.
Okay.
It's by type, you know.
Yeah.
And it's basic. It's everywhere the same. I mean. We just started the operation or doing some POCs even in the Middle East. I just came back from Oman. Where we said to us, because we are operating successful in Europe, and there was the question, how is the different climate zone? Yes, the climate zone is the different, but the pattern and the operations in the building stays the same.
Okay.
So is the same with this type of savings we can achieve, and I can indicate 3 of them. I will jump later on to showing some examples of that, but it's the first type is that systems are malfunctioning. I mean, and most of the time you can find out these possibilities to save in the algorithms. For example, there is no demand for cooling, which we have in Europe for like 3 months per year. And it's like in the morning it might be needing to have a cooling.
Yeah.
Later on you don't need that. So if you don't have a cooling demand into the end device, the whole units or fan coils, the algorithm of the building should say switch off the circulation pumps and please go to the chillers off, or just use the cascade using only 1 chiller instead of 3 when this demand is big.
Okay.
So this is an example of like algorithm failure of the building as all to operate in an efficient way.
Yeah, but does the BMS systems show, let's say, such a triggers?
I mean, we have to understand it's just an example from 200 different or 300 different algorithm tests.
Okay.
95 of the systems do not have this kind of approach. 5% of the systems might have this kind of approach, and it's implemented. So you can find in your building, if you had a building, there's this rule is already described, but it might not be described. And I don't want to talk on one of the rules. I want to say that there is a package of rules, and you never know where you are like failing.
Okay.
So one point is algorithm failures. Another one is mechanical errors or human factor errors. So you never know when your frequency driver will go and it will be pushed like instead of auto, it will be manual.
Okay.
You never know when the actuator breaks. So this is, you have to check these, and by finding them really fast, fixing them.
That means save the energy consumption and at the end of the money. Yeah.
Exactly. Okay. And very important, the third one is, I call it overhead. If we are going in any of the APC contracts and we calculate the energy saving which can be resulted, at the same time we are talking about KPIs of microclimate. I mean, we are asking for the client what temperatures in what time of the day you want to keep, what CO2 level you want to keep. Do you have these numbers? And sometimes that's already a start to save, because they say, yes, I have to operate based on data of sensor, not from the idea how it should be. So most of the cases when we put these KPIs is for microclimate and we check the operations of the system at the same time, we can see that there is a huge difference. Systems are operating to keep these results, and you can just load down the intensity for, I don't know, if the CO2 level is like 450. 24/7. Outside is 450 at the same time. Fan speeds are at 100%, so it's like it's overhead. Let's make it down and not reach more than 600, which is already very good.
And I guess nobody cares as long as tenants feeling comfortable.
Exactly. But this, I mean, if it's 600, which is very good measure, everyone will feel good. No one will see that difference, but energy bills will reduce definitely. So this is the third type, and. When you're asking about the cases, and I'm already giving you some examples, and there are some groups, and in these groups are getting the data. So in the platform we are having, we just indicated also similar groups. You see that by types. We are tracking the algorithm checks. We are seeing the comfort indications, mechanical tests. We even check the setting changes, because option 2 is human factor. Someone is changing the set points and so on. We want to catch this in the platform. So by doing this, process, you already understand that there is much more higher level of control what's happening in the building.
And you're always up to date. That's the most important thing, I guess, for the owner.
Exactly. And but there is still not enough. Remember, I said if you have the list, you have to make the action. So in the platform we are using, we can take any of the insight. I don't know. Let's check. Comfort time should start earlier, too cold in the morning. So this is the.
So the platform gives you advice when to start.
Exactly, it calculates and it checks, because we agreed on some specific temperature at 7 o'clock. And in the building there is a comfort time and there is economy time. And sometimes buildings are having like a period to reach from comfort from economy to comfort. So you can put comfort and economy schedules. Without our system, it's done like, I don't know, maybe it's too cold, I will make it early or sooner. Our system calculates.
I never seen those such a things in any BMS system, so it's pretty,
it's left to a person to decide, and we want to help person to calculate and then to decide. So our system calculates, but in this specific example, comfort time start should be earlier. We have a comfort problem. It's getting colder now in Lithuania, and the previous settings are not applied anymore. So we get this indication, and there are two options from that period, and now I will explain the difference between number 4 of the level and number 5. That you can, option 1 in the level 4, yes, you can just go to BMS and make changes, and you indicate. I'm putting a lot of letters here, but I want an engineer to indicate the changes. I will show you later on why we need it. And we have this small input to just make comments by action performed, because later on I'll have to have a discussion with the building owner and show the comments, so show the actions. So
Okay.
we are registering the actions. This is the difference from.
It's like a ticket machine, yeah.
It's a ticket
Okay.
machine for like word orders and giving the statuses. You can put any like type for that. You can take any kind of like status tag for that, and if you have these kind of situations, and I see right now I just filtered one of them. If we have a lot of these cases, this is for different floors, for different areas, and human is doing this time after time changes manually. In the end of the day, we can go to the client and say, let's go it from level 4 to level 5 because we were doing it manually. But this is the real case. We have to automate and to give AI to decide this kind of solutions.
Okay.
So this is what I wanted to like to be followed, that AI can be used only by getting the insights, and later on you can go and jump into give these like agree with the maintenance and everyone that we are giving this performance to AI. Can I? Yes, let's try.
Okay, so first of all, you must be familiar with the buildings, yeah? And after that, when you are getting all those deep analysis, you can apply the fifth level on top of it.
That's the case, yeah.
Okay.
The next thing is that this is, if you follow the process, we get the insight, we make some actions. We have different kind of groups of actions, as I already mentioned, some comfort issues, some energy efficiency algorithm checks, some mechanical ones. As I mentioned, also we're just trying to track setting changes, and it also goes into that result of the saving. In the end of the month, we can have a statistics, and I'm showing you now in the dashboard the statistics we can follow on the monthly basis with different slices, done, in progress, forwarded for technical department. So
basically you track every single step you've made with the building during the period, yeah?
Exactly.
Okay.
Exactly. And as I mentioned at some other points, when we decide to do, we also track what AI was doing. So if we decided that the AI will change comfort time, we want to track it, and it should be in the system because even chatbots are making some mistakes, and we know a lot of stories. So we have to be aware of that. Everything has to be inside of that.
Okay. Yeah. So I don't know, Nerijus, maybe we have questions, any related.
While that, I just go into some. If there will be, maybe it's going to be in YouTube. We want to share with some people with some technical, because we said that it's going to be a case study review.
Yeah.
So I'll just hit with some other examples for our listeners or viewers on this webinar.
Yeah, so we can choose any topic, for the next time. But okay, let's say you already sold me this let's say solution, yeah. How about the onboarding process? Do we have time to discuss more about onboarding or?
I don't know what's the time level. I want to hit with some other examples before that, and I will discuss the onboarding later on. So
we can move there.
Let me share more like cases and examples, just random ones. It might make sense for the listeners.
Okay.
So in the next thing, we have another example. Remember, I was talking about the different groups, and just for you to understand what kind of other examples might be to catch up the algorithm problems. So I'm just filtered one of them. Remember, I showed it's possible to filter some of them. So I would see we have a WHO unit, and we have the system catch up that a WHO is not using a free cooling. It's like in the system it's possible, that free cooling is one of energy saving things, and how you use it is very important.
Yeah,
if you're not using it in our climate zone, it's like you're wasting money.
Yeah.
And this is quite like explaining how it catches up. You can see down below the idea of our platform, that if we check any of the insight, which is very convenient, and you will not find it in any BMS systems, we take the insight and it gives for us the specific numbers of data numbers of the system. and I can analyze and double check the inside. And in this example, I can see the parameters, and it's very important. We are different from other companies who are saying that I'm having an advisory systems or like analysis systems, which indicate some peak consumption from meters. They give indication and that's it.
It's more like monitoring.
It's monitoring, and it might be called analysis, but you have to go deep into analysis. And we are going into like fan speeds, temperature, coil operation, and so on. And this is in the example showing that for you see the numbers. We see fan supply fan speed. We see outdoor temperature. Again, it's the cross-checking of the information. We have supply temperature, and we see the cooling valve is operating. So you probably understand that if I have outside air like 14, 17 and so on, and my valve is opened, I'm not using a free cool. Outside is 14 and cooling is operating. So this is one of the example when you just, the data, for the engineer to catch this, you have to just scroll a lot of Excel. So our platform indicates that system.
So basically these windows are for engineers, for daily basis we're working with.
This is the case.
Okay.
And this is like algorithm check. Another thing which might be interesting. I don't know if we have still time to go through these.
We have a couple of minutes, yeah.
Okay, so the other example is again about algorithm. We can see change fan logic. Something is wrong with the fan logic, and it's very funny. We are finding it in many cases. Someone programmed 10 years ago the logic of the WHO unit, and WHO unit, if it's like enough, the CO2 level is good. They are using the same air to recirculate inside. It saves a lot. Okay. But at the same time, we're going even deeper and asking ourselves, so if the air situation, there are no people inside or only few people inside, and the air is fresh and the temperature is good, we are making recirculation at that time. We're asking, and our algorithm asking, what's with the fans? Why they are like, we're using the same air, why using the fan speed at 100% or something like that? So this is again the numbers which are showing it. We can double check and we can go into operational thing to change it, or to use level 5 and to override the algorithm after agreeing and showing it data-driven situations for our clients. So there are more and more of these cases. I'm hoping that it makes sense when we're talking about case studies that you are catching up these different types. Again, algorithm failures I was showing, mechanical or human factor, which is like it's happening every day.
It's enormous times.
Yeah, and the third one is like overhead, when no one is like thinking of let's make the KPIs and let's check at the same time what the systems are doing. So these three like big elephants in the room. We're working with them. We can go back showing to the client how much of them we catched up, how much we fixed them, and at the same time we're showing the results of energy saving. Okay. So this is like, you understand that we are going through all the 5 levels, and client understands and is aware of the savings he is having in the bills. So that's the overview and the operational process, which definitely works in the market. Okay,
so now it's clear for me how you came up, because there's the huge gap left, for you guys to operate in this field. So yeah. It's pretty good. So I don't know if we don't have any more questions. Let us check with Nerijus. No. Okay. So from all we just hear, the main key points for all of us trying to make buildings in the best possible operational way is BMS is not enough. To have in a building. So you never know what energy losses you face in this moment. So stay efficient. And see you next time in our webinar sessions. I guess for the next time we will choose one of the options of topics. I don't know, maybe more usage of artificial intelligence, or trends for CO2 emissioning and ESG taxonomy regulations. Okay. And for those who missed our podcast, you can find out in our website after www.exergio.com. So see ya and stay tuned. Yeah, thanks Donato for having you.
Thank you.